Today, we are introducing how to perform regularization training. Make comparisons between examples to show that regularization can achieve better model effects faster. Now we'll explain regularization through the following 4 aspects. 1. What is regularization? Regularization refers to adding extra images to improve the learning algorithm, which reduces the overfitting problem and enhances models' generalization ability. For example, there were 2 kids, A and B. One day in an art class, the teacher showed them an artist's painting and told them that was a chicken of the flatting painting style. Kid A had never seen what a live chicken looked like since birth and believed all chickens in the world were the same, white like a rice ball with bean-like eyes and black wings. The teacher assigned them homework to draw a realistic chicken with the flatting technique. This was Kid A's work. Chicken looked 99% similar to that artist's painted one. The other kid B had seen chickens before the class, so he knew there were various types of chickens. Hens and roosters, black, white, and colored. This was Kid B's work. Then take a look at our trained models. Just like those 2 kids. Regular dataset features learning knowledge first. With the knowledge learned in advance, models can use the new knowledge more flexibly. Sometimes models do not need to use knowledge flexibly. Like, if you try to draw a game character, a celebrity, or a certain product steadily with LoRA, you don't need to use the regular dataset. 2. What should be uploaded in the regular dataset? Upload images that can reduce a certain weight of the being trained material. Therefore, images in the regular dataset should have something in common with images in the training dataset, but they should differ in the aspect that you want to reduce the weight. For instance, the training dataset contains flatting animal illustrations, but you don't want the generated animal images from the trained models to be as abstract as those in the training dataset. You can upload some comic images with normal shape animals in the regular dataset. Another example, if the training dataset contains images of unicorns all with a white background, you can upload some unicorns with colored backgrounds, vivid expressions, and different art styles. The training effects will be compared and analyzed at the end of this video. Therefore, you can prepare the regular dataset based on the training dataset images and the expected training effects. Let's see how to perform regularization training. SeaArt training supports uploading images and tagging them online to create a training dataset. You can select the base model online for training. There are abundant professional parameters that meet complicated training demands. Never have to be troubled by various hardware limits and training errors of local training. First, app train. Create a dataset. Upload images. If you've already tagged the local images, you can also directly upload a training dataset with the tagged files. You can crop the images through the toolbar below and select the crop mode and the crop size. The toolbar also contains tagging algorithm and tagging threshold. Tap tag after the selection. You can also edit the caption of a single image by tapping the image. Edit the incorrect part of the caption. After completing the caption, tap Regular Dataset to upload regular images. The regular dataset does not need to be tagged. Then select a preset parameter, just the number of repeat and epoch. If you want to edit advanced parameters, you can tap Advanced Config to reset them. Next, edit the model effect preview prompts. Improve the prompts with words more in accordance with the training dataset content. At last, don't forget to fill in the dataset name. Tap Train Now. During the training, you can view the real-time loss value and sample images of the model. After training several models, let's compare the images to see the regularization effects. Here is a group of animal models with the flatting art style. Parameters of Group 1 and Group 2 are the same. Group 1 has not used regularization. Group 2 has used regularization. Please note that no matter how many images have been uploaded to the regular dataset, training steps will be doubled, which means the training time will be doubled. As we can see, with the same steps, Model 1 is fitted faster, learning the animal shapes and brushstroke art styles of the training dataset. But the generated images look weird due to the abstract art styles and too many animal types in the training dataset. Model 2 only learns a few brushstrokes with the same steps and doesn't learn well. But as the steps increase, the brushstrokes and art styles get better and excellent. The chicken shapes are even realistic, not like rice balls. The model's generalization ability is greatly improved. Then, have a look at the unicorn models. Model 5 has not used regularization, while Model 6 has used. The two datasets have a huge difference. Images in the regular dataset have more abundant backgrounds and more cartoon unicorns with vivid expressions. As to the training results, images from Model 6 have more abundant backgrounds than images from Model 5, and there are even some cartoon unicorns in Model 6. Although Model 6 has better generalization ability, its art style is affected by the regular dataset. Therefore, when training the art style, don't upload too many images with greatly different art styles in the regular dataset. The regularization training can targetedly prevent AI from being too rigid when learning and improve the generalization ability of models.